impact that that has on the way that you build the architectures that support your applications. So when you think about the way new applications are deployed these days, it's different than it used to be. It used to be that you had a full set of requirements developed before anything was built, but that's not the way companies do things now. Most of the time when companies start a new application, what they do is they start by developing an application that handles a small but really important part of the problem, not the whole thing, because the whole thing would be too much of an investment to start with a brand new application that you're not sure if it's going to work or not. So what do? You start by developing a minimum viable product. And this minimum viable product addresses a small but relevant part of your application. And then if that catches on, then you add capabilities over time in an iterative fashion. So start with the basics of the application, add a little bit more, a little bit more, a little bit more, a little bit more. So by doing this, you make lots of these small changes rather than a small number of really big changes. The reason that works so well is because you get good at it. When you do hard things often, you get good at it. If you think about what it takes to learn how to drive a car, learning to drive a car is really, really, really hard. But over time, you get better and better and better at it. So you want to do something that's really hard, do it often, and you'll get better at it every time. You guys have gotten much, much better at taking tests and exams. Why? Because you've been doing it for, what, 15 years? 14 years? Over time, you get better at doing hard things. So what are the kinds of applications that we have out there? Well, just really basic ballpark. We've got things like e-commerce applications. And Amazon.com, of course, is the best example of that, although there's gazillions of others. We have enterprise resource planning applications, something like SAP. Enterprise resource planning applications you use to coordinate the activities of lots of divisions within a business to create the final product. So ERP systems are usually used by large manufacturing companies that outsource a large part of their work to a large number of vendors so that they can coordinate everybody's activities to get everything done. Customer resource management, CRM applications, something like Salesforce is the best example of this. And the reason you want to use CRM applications is because it helps the sales side of your business coordinate their activities and to bring lots of people to bear on selling the product that your company makes. Search applications. Search is totally different than other kinds of applications. Google's a great example of that. There's lots of smaller search applications. We've got search on the rit.edu page. So, how does that work? Well, it's a different kind of an application. Social networking and blogging kind of applications. And Facebook is probably the best example of that. And it's a big database. And then finally, this last one, which is a really cool one, URL shortening. And we've all seen bit.ly URLs, and what you do is if you have this really long path to something on the internet, you can go to bit.ly and set up a much shorter path that gets to the same place. Well, how does that application work? Well, URL shortening is a great example because it uses caches so much. So you load this whole database that has the shortened URL here, the longer URL here. And when a user enters in the shortened URL, it returns the longer URL and takes you directly to it. But that's a really good example of a cacheable application in that you don't have the data that you're storing is so small that you can load it either all into cache or all into RAM or all into some sort of a very fast retrieval system. What's workload? Well, workloads are the things that need to be done to support an application is the best way to describe it. And the key concept of our course here is that what you want to do is you want to match the application architecture to the workload. So if an application requires that this happened, you build an architecture that supports doing that. That's the key concept. And we've got different applications that generate different workloads. So if you look at these kind of applications, they're all very, very different. Most of them are databases, as most things in the world are, but they're all very different in the workload that they generate. So what are the implications of attempting to match the architecture to the workload? Well, for one, no one architecture is good for all applications. They're all going to be different. Application architects need to have a very good understanding of the application before they can design the architecture. So if you come up with a new idea for an application, somebody's going to work with you to figure out how to support that idea, and what they come out with is going to be based heavily on their understanding of what that application needs. Changes to the workload can necessitate changes in the architecture. If you have a small application that does its thing and you built it as a monolithic architecture, that's great. But if the workload changes, if for some reason or other it gets popular, if for some reason or other what you serve out of that application changes, you're probably going to need to change the architecture because of the change in the workload. And then complex applications generate really complex workloads and require complex monitoring systems to keep track of them. So the complexity of applications these days is requiring us to build these really complex architectures and monitoring systems. Those are required because you need to know what's going on in any sort of an application. System management, it's impossible to manage a large monolithic application, mostly because it's hard to look inside that monolithic application. But if you cut up that large application into a series of microservice architectures, then you can manage those individual microservices in a better way than you could the large monolithic architecture. And that's a huge component for why monoliths generally don't last over time. So workload characterization, this is how you describe the workload that an application generates. You could call it capacity planning is another way to describe it. And the big question in this is, how do you predict the workload generated by a new application? And the answer to that is, generally speaking, not very well. People aren't good at it. Most of the time what you do is you will, if you have this new application, you're going to compare it to an existing application and say, how does this one work? And then by comparing how they're the same and how they're different, you can kind of come up with the ballpark of what to expect from this application. But as long as the application changes only slowly over time, then you're okay. But it's just when things change quickly, that's when you can get yourself in trouble. So workload characterization, more of an art than a science. People just give it a try, see what works, and then change what doesn't work. That's the general approach. So dream or a nightmare? So, the question is, and this is old, but it doesn't matter. The question is it a good thing or a nightmare if all of a sudden you get a big bump in workload. And here's an example of what's called the slash dot effect. Used to be the slash dot effect. What that means is that, there's, back in the day, I hate using that, but back in the day, there was a site called Slashdot. And if you put a website out there, you maybe had something not so cool on it, but then you put something on your website that was pretty neat. And then that was fine. It generated a little bit of bump in workload. But then if the site Slashdot picked it up and advertised it to the whole internet, you might get hammered with workload that you weren't expecting. Well, back in the day, and still today, you pay per transaction in many hosting environments for the amount of transactions that happen on your machine. And so if the Slashdot picked up your, cool little video or something like that, it could bankrupt you, because all of a sudden you get all these people downloading some goofy video that you put on your site. And, is it good that you got this big bump in traffic? Yes, but can you monetize that? That was always the hard part. Now, other applications, you see these seasonal spikes in traffic, where if you think about, Amazon.com or a site like llbean.com or some kind of e-commerce site that does a significant amount of business around Christmas time and whatever other holidays, they go crazy in workload around llbean around Christmas. But once you get into January, February, and March, there is nothing. And then it probably picks up again around summertime when people buy summer clothes, probably springtime when they buy summer clothes. But then it drops off again. So, some applications generate this really seasonal workload based on major holidays. And you can see you have the big seasonal workload and then these minor seasonal workloads too. Other companies like Intuit, this is TurboTax, but Intuit has the same problem where they do tax filings, income tax filings for individuals. Well, most of the year, their servers are probably just putzing along doing next to nothing. But then right around April 15th, they get this huge spike in traffic. And how do you build capacity to support that crazy workload? And by the way, Intuit always comes to our atrium to recruit. Who knows who will come this year? But if you're interested in this, as I understand it, they're a pretty good company. So, just a crazy workload that's very seasonal. Well, it's hard to support this. If you have a static data center and you've got crazy demand, how do you match your resources to your demand? And the answer is, it's really hard. So in a static data center, you have fixed capacity. And that fixed capacity, if you want to meet your seasonal demand, you have to have more capacity than you need at the highest level of demand. You're more than your peak level of demand. And that gets really expensive. What you would prefer would be something where you have the ability to match your capacity to the demand. And of course, that's cloud-based stuff, because that's the only place where you can actually do this. So you got unused resources, how do you pick the capacity level, blah, blah, blah. And then you have this huge sunk cost where you buy these machines that are just whirring away but doing nothing. So what you want, and we went over this in the last video, is this. You want this automated elasticity. Now, you may think that this is just a e-commerce kind of thing, but it's not. It comes up for lots of businesses. Lots of businesses have this seasonality, or they may have a special process that only gets used sometimes. For instance, every company has to close their accounting books at one point in the year. They have a fiscal year. It starts and then it ends. And when the fiscal year ends, they have to do a lot of summarization of their accounting application. Now, that's a process that only happens once a year. In reality, it probably happens at the end of every quarter, but let's just say once a year. And so having the excess capacity around to do that once a year kind of a thing is very expensive. And you know, when machines don't get used, how do you know they're still working? You should have lots of monitoring tell you that, but it's just hard to do. So, you know, having access to cloud-based architectures is just an awesome thing for lots and lots of different applications out there. So the workload needs to match the architecture. That's the main thing of this whole class, really, and your whole career is going to be spent doing that. And so I hope this helped. Take care, everybody. Bye.